So the first thing that we'll do is graph the base. What's the base here? What does it look like? A circle with center at 0, 0 and radius of 1. The radius is just the square root of that. So we'll graph that first. We know it goes from -1 to 1. That's 1. That's -1. Because the radius is 1. Are we okay with that? Maybe? And then it said that the cross sections are semicircles. Remember, the cross sections are coming out of the screen or out of the board, out of the paper. So I'm just going to pick a small one. It's like sticking up and out. I should do it. Does that make sense in your brain? That's sticking out of the board, the red semicircle. How do I get the area of a semicircle? Pi r squared divided by 2. So eventually we're going to have to use pi r squared divided by 2. And I'm trying to get the area of this semicircle, yeah? Is there any way that I can write the radius? I mean, that's the radius. Can we tell? Can we tell that? The radius is just half of that entire distance. The whole distance is the diameter. Does anybody know how we get this distance as a function of x? How do we get distances? To get the distance, we just have the bigger function, which is the top of the circle. And I want the distance to here, so -0, right? We just need to know the function for the top of the circle, right? Do we know how to get the function for the top of the circle? We've done this before. You just take this and solve for y. You'll get plus or minus the square root of 1 minus x squared. The top of the circle is the plus part, right? Okay, so we'll do that. We have... Do I need to show you guys solving for y? I'll do it anyway. So we have x squared plus y squared equals 1. I want the function for the top of the circle, for the top portion of the base. So I'll take this and I'll solve. I'll get y squared equals 1 minus x squared. I just subtracted x squared from both sides. Square root, and I get plus or minus the square root of 1 minus x squared. But really I want the top part, so I'm just going to use the positive. So now this distance is just the square root of 1 minus x squared minus 0, or r. Our radius of the semicircle is just square root of 1 minus x squared minus 0, but you don't have to put the minus 0. That's just this function minus this function. So then how could I find the area of this cross section? What would I do? Yeah, plug it into that. So the area function would be pi r squared. R is the square root of 1 minus x squared, divided by 2. Yeah? Are we okay with that? Okay, then how would you get the volume then generated by this cross section? Like what's the integral that I write? What's that? Anyone?
Is the integral of -1 to 1 of a of x, which is downward.
Yep. Is that it? Is that all we have to do? You're right. That's how you set it up. You can do this. This one comes out to be like you're able to do this by hand because the square and the square root cancel. So that's kind of nice. So you could do this one by hand if you want, or you could just do it in the calculator. Are there any questions on this? Yeah.
Did that get divided by 2?
If you had the top part, oh, I see. If you just wrote this,
Yeah.
would it go to 0? I don't think so. If you integrate this from -1 to 1, the solid just looks like half a sphere, right? If you had the cross section being the entire circle, meaning you don't divide it by 2, then you would get a full sphere. That make sense? So, yeah. Hopefully, like you don't have to practice integration anymore, so that you can just do all these in the calculator. Some of them you won't be able to do by hand anyway. So now's the time to try and set it up and then practice doing it in the calculator, making sure you're doing it properly.